Okay, so second part here. How do we actually do the pH calculations? Well, what we're going to do is the pH scale is based upon the base log base 10 scale. So everything's an exponent based upon an exponent of 10. So if you write these down, and we'll talk about them some more here, the pH is equal to the negative log of the hydrogen or hydronium ion concentrations. The pOH is equal to the negative log of the hydroxide concentrations. And again, we remember pH plus pOH equals 14. So let's just say we have two chemicals, and this is the concentration of those two chemicals. What I want you to do, you can pause this, is I want you to calculate the pOH for this one, and I want you to calculate the pH for that one, and see what we get for answers. So you can pause this, I'll have you take a look at it, get some answers, and we'll talk about what you... All right, when you do these calculations, your two answers should be 10.1999 and 3.7986. And now you're probably wondering, all right, well, how do I do these significant figures? Well, it's a little bit different, but it's still pretty easy to understand. Here's how it is. The number of digits that are in the concentration, in the molarity. So if we look at both of these, it's 3. Then that's how many decimals you can have in that px. So that's how many decimals you can have in pH or pOH. So I've got 3 digits in the molarities. I can have 3 decimal places. So this would round to 10.200 and 3.799 would be the two answers. All right. So that's what we want to be able to do, is we want to be able to take those numbers and calculate a pH value. Now, there's other things that we need to be able to do also just besides those. So we also need to be able to work the other direction. And we'll kind of talk about that here next. So here's the first thing. I want you to solve for the pH and the pOH given that concentration, 3.95 times 10 to the minus 7. I want you to find pH and pOH. Okay. And I want you to use one of those 3 calculations. Those are the ones we probably use the most. But also, we have this fourth one that people sort of forget about. So you're given the concentration of hydroxide. You can get to pH, and you can get to pOH. There just is a couple steps involved to do that. So, to do again one more time here, a little bit different here. I'm only giving you one number, but you got to find several different numbers. Okay, not the pH and the pOH. Okay? So you can pause. Okay, so here's one way, and again, there could be a couple different ways this could occur. If you want to find the pOH first, we just simply take the negative log of that number that we're given. So we take the negative log of the 3.95 times 10 to the minus 7. And you should have gotten a pOH of 6.403. Then you could have subtracted that from 14 to get a pH of 7.597. You also could have said, you know what, after I get the pOH, I'm then going to use this equation to solve for H3O plus. And once I've solved for H3O plus, I now can then take the negative log of that and get my answer also. So that's where you're going to realize here there's 2 different ways that we can do this calculation. And you need to be, feel comfortable doing it either way. All right. So if we're doing this, the one thing we haven't talked about yet is how do we actually go the other direction? We're finding pH, we're finding pOH. How do we find the concentration from a pH? Well, so we have to take, kind of have to undo 10 to the x power. It's what we call the antilog. Now this is real simple. The antilog is just the 10x key on your calculator. You got the LOG button, and then you got the 10x, which is the second function. So if we want to find the concentration of H3O or OH, we just take the antilog of those pH or pOH values. So what does that really mean? That means to find the concentration, we're just going to take 10 and then the power is going to be the negative pH if we want to find H3O. So 10 to the negative pH gives us this number. 10 to the negative pOH gives us that number. And that's pretty simple. We're all worried about logarithms, but it's pretty straightforward. So here'd be two that I want you to do just to make sure that you get these answers. If you're given the pOH of 6.27, and I tell you to calculate the hydroxide concentration, you should get an answer of 5.4 times 10 to the minus 7. Okay? I want to find the concentration. I'm going to take 10 to the negative 6.27, and that should be your answer. If I want to find the hydronium ion concentration, I'm going to take 10 to the negative 7.73, and these should be the two answers that you get for those. All right. We will definitely do some of these in class. Once you give it a hang of it, they're pretty easy. All right, last thing here. Here's kind of how the problems are set up. You're going to somehow have to solve for those. The pH, the pOH, the H3O concentration, the OH concentration. From that, these are the equations that you will use. Now, the two here in the middle, I put a 2 next to them because I just put px. There's really pH equals, and there's pOH equals. Just like down here, this is 10 to the minus pH, 10 to the minus pOH. So you've got really 6 equations that you could use to find any of those missing pieces. And the last thing, remembering how we do rounding for those. Okay. And you will need to remember those equations. Those aren't equations that I'm going to give you. All right, last two little things here. Well, how do we calculate some concentrations if we're given a chemical? We got to watch out for this a little bit. Let's first talk about bases. If the question says I have this concentration of the chemical sodium hydroxide, then the concentration of hydroxide ions is exactly the same thing. Oops, and that's a typo there. 2.35 times 10 to the minus 2. It's a 1-to-1 relationship. The molarity of NaOH compared to the molarity of hydroxide is 1-to-1. That's just like saying if I have 10 NaOHs, I have 10 OHs available. Now, where the difference is calcium hydroxide. If this is the molarity of calcium hydroxide, the amount of hydroxide ions, the molarity of that is twice that number. Because again, we have this 2-to-1 ratio. Calcium hydroxide compared to hydroxide ions is in this 1-to-2 ratio. So if I have 10 calcium hydroxides, I really have 20 OHs. We understand that concept, that counting of the 10s and 20s. Molarity is exactly the same way. So that's all you got to watch out for. If they're in the question, they don't just straight say concentration of hydroxide is this, and you go on your way, but they tell you the concentration of a chemical. The only thing that affects pH is that hydroxide. That's what we care about. So you've got to pay attention to that subscript. Acids are different. Remember, acids, we learned this in the last chapter, they're only going to break off one at a time. So we don't have to worry about that subscript. It doesn't matter. So if this is the molarity of HCl, then that's the molarity of H3O, or hydrogen ions. If this is the molarity of H2SO4, then that's the molarity of H3O, or again, H+. So the Cliff Notes version is simply this. The subscript on a hydroxide is important in terms of concentrations. The subscript on an H in acid is not important. So hopefully from that, we can figure out some different things dealing with the concentrations and the different calculations for acids and bases, and it's not too much of an issue. We will talk about some more things about acids and bases in a little bit, and one of these days. And one of the things we'll talk about is, well, which really is stronger? Which is more dangerous? An acid or a base? And a neat little trick is to use aluminum foil to do that. So like I said, we will do that at some point early in the chapter.